Hi everybody, this is Let Matolia from CDKTC Netcom Jaipur. Today we are discussing how to write the pointers concept in C language. So we are discussing some interview questions in C language in advanced topic. So what is generic pointers in C? Do you know about it? So void pointer in C is known as generic pointer. Generic pointer is a pointer which can point any type of data. So for example, suppose if you want to write the generic pointer, then you have to first write your data type, then with the star operator you can write your variable name. So you can write void star ptr. So here ptr is generic pointer. Now important points about generic pointers in C is what? We cannot dereference generic pointer. It means that suppose if you are taking void as a generic pointer, now suppose if you want to print %d star ptr, means it will generate some error. So error name is not an allowed type. So it will generate compile time error, not an allowed type. So you can't take generic pointers as a dereference. We can find the size of generic pointer using size of operator. So by using size of operator you can print the size of any type of pointer variables. So what is the size of pointer? We are having the 2 size. So any type of near pointer in C is of 2 bytes. If we are declaring variables without any type, then default type of pointer variable is of near type. So size of any type of near pointer in C is of 2 bytes. Generic pointer can hold any type of pointers like character pointers, struct pointers, array of pointers, etc. without any typecasting. Any type of pointer can hold generic pointer without any typecasting. It means that we are taking one example. Here we have declared one character variable C is equals to single quote A, integer I is equals to 4, void star P. Now we have to create one another variable character star P is equals to address of C. Means we are initiating address of C in a variable Q. Now we have another pointer variable int star R is equals to address of I. Now we are associating P is equals to Q. Means we are giving the value of Q to the P. So Q contains the address of C. Now we are associating to the P. So if you want to print the value of P, so you have to typecast and then you can print the value of C. So here you have to write character star and then P. Now suppose if you want to print the value of integer variable, then you can write P is equals to R. You can dereference it and then you can print it. So what is the output of this question? You can print as A4. A is the value of C variable and 4 is the value of I variable. So by dereferencing you can print it. So A4 is output. Generic pointers are used when we want to return such pointer which is applicable to all types of pointers. For example, return type of malloc function is generic pointer because it can dynamically allocate the memory space to store integer, float, structure, etc. Hence, we typecast its return type to appropriate pointer type. Now we are taking one example. Suppose if you are declaring one character pointer C, so you can allocate memory to the C variable. So you can write C is equals to character star malloc. Then you can write size of character. So we have allocated memory to the character variable. Now suppose if you want to allocate memory to the double variable, then first you have to create the pointer variable as double type. So double star D, and D is equals to, in brackets you can write double star then malloc size of double. Now suppose if you want to allocate memory to the struct node star type, so you can write struct student. Then in student you can create one character pointer variable as name, integer, roll number. Now you can create one variable for structure, so you can write struct student star stu. Now you have to allocate the memory, then you can write stu is equals to struct node star struct student star malloc then size of struct student. Okay, now next question is what? What is null pointer? So what is the null pointer? Null pointer is a pointer which is pointing to nothing. Null points the base address of segment. We are having the two address. One is the segment address and one is the base address. So we will discuss about the segment address and base address later in this slide. So we are taking some examples for null pointer. So first example is integer star ptr is equals to, you can typecast int star type as 0. Then float star f ptr is equals to float star 0. Character star ptr is equals to character star 0. Double star ptr is equals to double star 0. Character star ptr is equals to, in single quote you can write null pointer. Character star ptr equals to, you can directly associate with null value. So where null is defined. So null is a macro constant which has been defined in the header file stdr.h, alloc.h, mem.h, stddef.h and stdlib.h as has defined null 0. So we are taking some example for null pointer. So what is the output of this question? We are taking void main, if not of null then printf cdec x, else printf Rajasthan. So output is cdec x. What is the default value for null? Null is defined as 0. So not of 0 is equals to 1. So if 1 means condition true, so condition true means you can print cdec x. So if condition any non-zero number mean you are having the true condition, so you can print cdec x. So what will be the output of the following C program? So we are having one integer variable as I, static int count, one for loop I is equals to null, I less than equal to 5, then count plus plus, then I plus equals to 2. Now we are printing the value of count. So default value for null is 0. We are having static variable int count, so count default value is 0 because static variable takes default values as 0. Now we have to traverse this loop from 0 to 5. So I incremented by 2, so count incremented by 1. So what is the output? This loop traverse till 5, so output will be 3. So what is the result of count? Count is having the value 3. Now what is the output of this question? So we have redefined the null with the value 5. So here you can include has define null 5. So what is the default value for null? In this question we have reinitiated with null value with 5. So 5 plus size of 5, it becomes 7. What will be the output of the following C program? So we have declared one character pointer str equals to null. So if you want to copy with strcpy null with the cdec, now it will print undeterminate values as null. So what is the output? Null. So strcpy is the inbuilt function which can copy one string into the another string. So here we are having string as null, so you can't copy another string to the null. So what is the result? You are having the result null. So what will be the output of the following C program? So we are having some pre-process directive if and if null has defined null 10, then and if. Now we are printing the value of null plus size of null. So what is the result? 2. Null is having the value 0 plus size of null. Size of null means 2. So 0 plus size of 0 equals to 2. So 0 plus 2 is equals to 2. So size of int data type is of 2 bytes. So you have to remember size of int data type is of 2 bytes. So what is the wild pointer? A pointer in C which has not been initialized is known as wild pointer. For example, suppose if you are taking one pointer variable as integer type, so int star ptr. Now suppose if you want to print the value of ptr, so first you are using %u, means we are printing the address of ptr. Now we are printing the value at that address, so %d then star ptr. So we are having any address by using ptr, and star ptr means garbage value. So here ptr is wild pointer because it has not been initialized. So not point, there is difference between the null pointer and wild pointer. What is the difference? Null pointer points the base address of segment, while wild pointer doesn't point any specific memory location. Fine. Now next question is what? What is dangling pointer? Do you know about it? Yes or no? Okay. So what is the dangling pointer? If any pointer is pointing the memory address of any variable, but after some variable has deleted from that memory location, while pointer is still pointing such memory location, such pointer is known as dangling pointer, and this problem is known as dangling pointer problem. So what is the example? So initially, suppose if you are having some ptr variable as value 500, and what is the address of ptr? 800. Now we are having one variable a value with 25, and what is the address of a? 500. So we have initiated ptr is equals to address of a. So ptr value we are having as the address of a. Now after some time, suppose if we remove the variables, because scope of variable a becomes dead, now still ptr is again pointing to the variable a. So ptr is known as the dangling pointer case. So what will be the output of the following C program? We are having one prototype declaration at the top of void main function. So int star call is the function name. Now we have declared one integer star ptr. So ptr is equals to call function fflushstdin. It will buffer, it will clear the buffer area. Now printf %d star ptr. In function definition, we have written int star call function int x is equals to 25 plus x, now returning address of x. So in function definition, we are having one local variable x is equals to 25. Now we have incremented x by 1, means value becomes 26. But scope of the local variable is within the function definition only. Now suppose if you are returning the address of x, means the scope of variable x terminates. Now we are having the value of ptr as the garbage value. So output is garbage value. Why garbage value? In some compiler you may get warning messages returning address of local variable or temporary. So explanation is what? Variable x is a local variable. Its scope and lifetime is within the function call. Hence, after returning address of x variable, x becomes dead, and pointer is still pointing ptr, is still pointing to that location. So what is the solution for dangling pointer case? You have to make the variable x as static type variable. Fine. So different type of pointers in C. We are having basically three types of pointers. In Turbo, there are three types of pointers. Turbo C works under DOS operating system, which is based on 8086 microprocessor. So we are having three kinds of pointers. One is near pointer, second one is far pointer, third one is huge pointer. So what is the near pointer? The pointer which can point only 64 KB data segment, or segment number is 8, is known as near pointer. The near pointer cannot access beyond the data segment like graphics video memory, text video memory, etc. Size of near pointer is 2 bytes. With the help of near pointer, we can make any pointer as near pointer. So for example, you can see the segment number 8 is known as data segment. Fine. So what is the output of the following code? We have declared one variable int x is equals to 25. Now we have declared one variable as near pointer type. So we are referring ptr is equals to address of x. Now we want to print the size of ptr. So any type of near pointer is having the size of 2 bytes. So what is the size? 2 bytes. Size of any type of near pointer is 2 bytes. So what is the output of the following code? We have declared one int near star ptr. Now we are printing the size of ptr comma size of star ptr. Means we are having that 2 and then 2. Explanation: size of any type of near pointer is of 2 bytes. So near pointer only holds 16-bit offset address. Offset address varies from 00000 to FFFF in hexadecimal format. Now in printf statement to print the offset address in hexadecimal, you can use %p. So %p is printing in the hexadecimal format. So we have written one variable I is equals to 10, int star ptr is equals to address of I. Now you can print by using the printf statement. So you can write printf inverted comma %p then ptr. So what is the value? So you are having the result FFF4. We are printing the address ptr. ptr is equals to address of I, means offset address in hexadecimal number formats we are printing. %p is also used to print any number in hexadecimal number format. For example, suppose if you are taking integer x is equals to 15, now you want to print %p and then x. So what is the result? 000f is your hexadecimal value. So hexadecimal value of 15 is f. So by using %p you can print in the hexadecimal format also. So what is the output of this program? We have declared one variable near star ptr. So we have associated with the hexadecimal value. Now we have incremented ptr by 2, ptr plus plus and ptr plus plus. Now we are printing the ptr address. So what is the result? 0003 is the final result. Okay. Find the output of the following program. We have associated one star ptr as the near pointer. So we are traversing from 0 to 10 and then we are printing the value of ptr. So we are incrementing ptr by 1. So what is the result? We are having the result as FFFA, FFFB, FFFC, FFFD, FFFE, FFFF, 0000, 0001, 0002, 0003, 0004. Explanation: when we increment or decrement the offset address from maximum and minimum value respectively, then it repeats the same value in cyclic order. This property is known as cyclic nature of offset address. So cyclic property of offset address means if you increment the near pointer variable, then move clockwise direction. If you decrement the near pointer, then move anti-clockwise direction. Okay, so this is your offset addresses. Fine. What is the far pointer in C? The pointer which can point or access all the residential memory of RAM, i.e. which can access all 16 segments, is known as far pointer. So what is the size of far pointer? Size of far pointer is 4 bytes or 32 bits. So you can see here you are having all the pointers associated with the segments. So we are referring all the memory location with the far pointers. So find the output of the following program. So we are having one variable int x equals to 10, int far star ptr, ptr is equals to address of x. Now printf %d size of ptr. So what is the size of ptr? As the far pointer is having the size 4. So any type of far pointer is having the size 4. So what is the output of the following program? Int far star near star ptr, size of ptr comma size of star ptr. So ptr is 4 byte and star ptr is ptr is 2 byte and star ptr is 4 byte. So here ptr is near pointer while star ptr is far pointer. So near pointer is having the size 2 bytes and far pointer is having the size 4 byte. So what is the output of this question? We are having two far pointers and now we are printing the size of far pointer P and size of far pointer Q. So we are having the result 4, 4. In far pointer, you are having two addresses. First one is segment address, other one is offset address. So first 16 bit stores address as segment number and next 16 bit stores address in offset form. So find the output of the following program. So here we are having one integer variable x is equals to 100 int far star ptr, and ptr is equals to address of x. Now we are printing the value by using percentage capital FP then ptr. So by using percentage FP you can print the full address with the segment number and offset number. So what is the result? So we are having result 8 ff2 colon sign ff4. So here 8 ff2 is segment address and ff4 is offset address in hexadecimal number format. So not percentage FP is used for print offset and segment address of pointer in printf function in hexadecimal number format. In the header file dos.h there are three macro functions to get the offset address and segment address from far pointer and vice versa. So by using these macro function you can print individual offset address, individual segment address, and you can build both the segment address and offset address with the single one. So fp underscore off, by using this function you can get the offset address from far addresses. fp underscore segment to get segment address from far address. mk underscore fp to make far addresses from segment and offset address. Now find the output of the following program. So int x is equals to 100, int far star ptr, ptr is equals to address of x. Now we can print by using percentage x, you can print individual address of the far pointer in the form of segment and in the form of offset. So by using fp underscore scg you can print the segment address, and fp underscore off you can print the offset address. So what is the segment address? 8 ff2, and what is the offset address? ff4. So any segment and offset address in hexadecimal number format respectively. So find the output of the following program. We are having one variable integer x is equals to 100, int far star ptr, unsigned int s comma o, then ptr is equals to address of x. So we are fetching the individual segment address and then offset address by using fp underscore scg and by using fp underscore off. So fp underscore scg will return your pointer's segment address. So we are storing in a variable s. fp underscore off will return your offset address, and we are storing in a variable o. Now we want to build the wall address with the mk underscore fp. So by using mk underscore fp you can combine both the segment address and offset address. So you can print the segment and offset address by using the percentage fp. So what is the output? You are having the output 8 ff2 colon sign ff4. So we cannot guess what will be offset address, segment address and for address of any far pointer. These addresses are decided by operating system. So limitation of far pointer. So what is the limitation of far pointer? We cannot change or modify the segment address of given far address by applying any arithmetic operation on it. That is, by using arithmetic operator, we cannot jump from one segment to another segment. If you will increment the far address beyond the maximum value of its offset address, instead of incrementing segment address, it will repeat its offset address in cyclic order. Okay. So find the output of the following program. We are having one integer variable x, character far star ptr. So we are storing one far address with the hexadecimal value. So by using for loop you can print your values here. So you can print ptr, and ptr is incremented by 1. So what is the output? This property of far pointer is called cyclic nature of far pointer within same segment. So segment address can't be changed, but offset address will be in the cyclic order. So what is the output? B000 remains same, but FFFA, FFFB, FFFC, FFFD in this order we are printing the value. So important points about far pointer. Far pointer compares both offset address and segment address with relational operator. So in this question you can check, we are having two far pointers with the value associated 0x70230000 and another variable with the value 0xb0210000. So we are comparing P equal Q, means we are comparing both the segment address and offset address. So here we are having the different values. So P can't be equal to Q. So we are having the result as both pointers are not equal. So what is the result of this question? Here suppose if you are declaring far pointer star P, far pointer star Q. Now we are having two integer near pointer X and Y. So we have converted your far pointer into the near pointer. So X and Y is known as the near pointer. So if you are comparing X equal Y, means both pointers are equal. In this case we are comparing only the offset address, not the segment and offset address. Okay. So in this case we are having the result both pointers are equal. Now Hughes pointer, the pointer which can point or access all the residential memory of RAM, i.e. which can access all the 16 segment, is known as Hughes pointer. So size of Hughes pointer is 4 bytes or 32 bits. So you can see here the example. Hughes pointer is again also pointing to all the memory segments. Fine, same as far pointer. But what is the difference between far pointer and Hughes pointer? Far pointer is having the segment fixed but offset is changeable. But in case of Hughes pointer you have to find the memory normalization. Okay, so what is the normalization concept? So we will discuss in this session. Okay, but before that we have to find some output of this question. So character Hughes star far star P. So in this question what is the output of P, what is the output of star P, and what is the size of double star P? So P is having the size 4, star P is having the size 4, double star P is having the size 1. So here P is far pointer, star P is Hughes pointer, and double star P is character type data variable. So far pointer is having size 4, Hughes pointer is again having the size 4, and star P is having the character variable. So we are having the size of character variable as 1 byte. Okay, so what is the normalization of Hughes pointer? Turbo C compiler is based on 8086 microprocessor in which physical address of memory is represented in 20 bits. Conversion of 4 bytes or 32 bits Hughes address into 20 bits actual physical address is known as normalization concept. In short, if you want to convert 32-bit address into the 20-bit address, then this concept is known as the normalization concept. So what is the formula for calculating the physical address? So we are having the two formula. If you want to calculate in decimal format, then you can write physical address is equals to segment address multiplied by 16 plus offset address. In hexadecimal format, what is the formula? Physical address is equals to segment address multiplied by 0x10 plus offset address. So in Hughes case you have to find the normalization concepts. So what will be the physical addresses of Hughes address? 0x59994444 if you are having some address as Hughes address. Now what is the Hughes address in this case? 0x59994444 is the Hughes address. Now what is the offset address? Last address is known as offset address and first address is known as segment address. So what is the offset address? 0x4444 and segment address 0x5999. So what is the formula? Physical address is equals to segment address multiplied by 0x10 plus offset address. So you can write your segment address multiply with 0x10, you can add with the offset address. So what is the result? We are having the result as 0x5DDD4. Fine, understand this concept? So in binary form we are having the result 0101 1101 1101 1101 0100. For example, we have done this case. So each hexadecimal digit is represented in 4 bits binary number. So we have done the normalization concept. Means 32-bit address is converted into the 20-bit offset address, 20-bit address. So when any relational operation is performed between two whose pointer, first it normalizes in actual physical address, then after we can make the relations between these two variables. So for example, suppose if you are taking two huge pointer as P and Q, and if you are comparing both the variable as P equal Q, so what is the result? Equal or not equal? So it depends upon the normalization concept. So first you have to convert P into the normalized form and Q is again into the normalized form. So actual output is equal. As we know, whose pointers compares its physical address. So what is the case? So we are explaining this concept. So physical address of huge pointer P. So huge address is what? 0xC0563331. So in this case, offset address is 0x3331, segment address 0xC056, physical address is equals to segment address multiplied by 0x10 plus offset address. So you can write 0xC056 multiplied by 0x10 plus 0x3331. Now you can write 0xC0560 plus 0x3331. So after adding these two values, you are having the result 0xC3891. So finding the normalization of Q variables, or you have to find the physical address of huge pointer Q. So huge address is equals to 0xC2551341. So in this case, what is the offset address? 0x1341, segment address 0x32C255. So physical address is equals to segment address multiplied by 0x10 plus offset address equals to 0xC255 multiplied by 0x10 plus 0x1341. So equals to 0xC2550 plus 0x1341. So what is the result? 0xC3891. So physical address of P and Q both are equal. So it means you are printing the result as equal. Since both huge pointer P and Q are pointing same physical address, so if condition will be true. So what will be the output of C program? Suppose if you are taking one double near star P, comma far star Q. Now we are printing the size of Q, size of P, size of star P. So 4 is the size of Q, 2 is the size of P, and 8 is the size of star P. Here Q is far pointer, P is near pointer, star P is double data type constant. Fine. So don't use huge pointer. So if you are using huge pointer, means if you are incrementing huge pointer, it will increment both offset and segment address, unlike to far pointer which only increments offset address. Okay. So by using huge pointer, you can easily access and modify the IVT. IVT stands for interrupt vector table, comma, device driver memory, comma, video memory, etc. This might be dangerous for your computer. Means if you are using huge pointer, means you have to care about the memory addresses. If you are having some important data at that memory addresses, and if you are updating some pointers at that memory locations, means your data is updated. Now if you are having your data as important, means your data can be corrupted. Okay, fine. So thanks for watching this channel. If you are having some query regarding pointer concepts, so you can mail to us as npltech85@gmail.com. You can also visit to my blog lalitmatolia.blogspot.in and also npltech.blogspot.in. I will also write some more blogs on the different concepts, just like as Android, iPhone, cloud computing, search engine optimization, WordPress, Joomla, etc. etc. My contact number is 9983778429. You can also visit to my website http://npltech.in, and you can also visit to my official website http://seedexepu.in. So thanks for watching this channel.